Okay, welcome in Precalcsters. Today we get to start our first chapter. And in chapter 1, our focus is going to be something that we've studied quite a bit of. Remember, the first few chapters are going to be just a really quick, essential, like Algebra 2. We're just going through everything. We're blasting through it. If you need help with stuff, because pacing is not as adjustable in here, when can you come see me? Before school? At lunch? Yeah, 6th hour. If you happen to have 6th hour free, you can stop in here. Will I answer emails if you send me math questions? Most likely, yes. Barring some terrible busy night or something, but yeah. Okay, so we are looking at rectangular coordinates, and I don't think I'm even going to write the first bit down. It is entirely up to you guys if you want to write this down, but this is going to take like 10 seconds. I'm going to stick with this red color until I think that it's probably time to start writing. You can write if you want to. Okay, rectangular coordinates. What are we talking about? The coordinate plane. Okay, the Cartesian plane, piece of cake. The Cartesian plane has 2 axes. What are they? Okay, show me with the most exaggerated hand movement what the x-axis is. Okay, awesome. Everybody did one of them's x. There it is. Okay, x. So we have this to be the x-axis. Boom. Okay. What's the other one? The y-axis. Okay, and we're not, like, again, up to you if you want to write it down. I don't think you guys will need to. What is, just looking at this, what's this point called? The origin. What's its ordered pair? Which one's x? Can we agree with the first one? X, y. Okay, awesome. Okay, over here, this is a fourth of this whole plane. What do we call this region up here? Quadrant 1. So check it out. We have quadrant 1. Where's 2? Okay, so when we work through this, we're going to go through a circle, right? Do we go counterclockwise or clockwise? Counter. So here's quadrant 2. Down here is quadrant 3. And over here is quadrant 4. Now, if I pick a point in quadrant 1, and we're just going to do some random numbers, you guys all remember your numbers now? Okay, and there's 21 of us in here. That did not do the right thing. So let's do this again. All right, number 21. Are you in here today? Yeah. Okay, give me a point, any point in quadrant 4. Yep. 1, -3. 1, -3. Do we agree with that? Yeah. All right, number 1, give me a point in quadrant 2. Give me any ordered pair that you would find in quadrant 2. -5, 3. Negative x, positive y. We're good. Okay, as we're going through this, just real honesty, do we need to have you guys go up and plot a few points on the board right now, just as a review? Okay, so the majority are no. We will get time to go up, don't worry, but it's not just going to be plotting points. Okay, I think we can all plot these points. Now, as we get in with this, the whole benefit to having this rectangular coordinate system is it lets us think about different ideas in a different lens. So before, geometry was completely different than algebra. They didn't mix, they didn't match. René Descartes, why it's called the Cartesian plane, had this realization in the 1600s, I think, where he said, hey, if we do this, we can now think about geometry with algebra and algebra with geometry. And these two fields started to kind of blend together. As we do that, when you think of geometry, you probably remember quite a few theorems. I don't know how many specifically. Are there any specific theorems that you remember from geometry that maybe you saw in other math classes? The Pythagorean theorem. Love it. That's where we're starting. So in these rectangular coordinates, we are going to have our first little subsection, and I'll stick with this green color. We're going to talk about the Pythagorean theorem, and I'm just going to shorthand that. I lied. I'll write it once here. This is going to be the shorthand moving forward. Pythag. Actually, I call it Pytheorem, but Pythagorean, no M's in here. Hooray, Pythagorean theorem, and distance. And I don't know why this is coming out all caps because this isn't a vocab, but we're going to use it. Okay. What's the Pythagorean theorem? A squared plus b squared equals c squared. I like that idea. Ooh, I like the word that Kian used here. He used a word that nobody else did. He didn't just say a squared plus b squared is c squared. He used the word hypotenuse. which means the second the word hypotenuse gets used, we're thinking about what sort of triangle? Right triangles are the only ones that have hypotenuse. So if we're thinking about this, we all know a squared plus b squared equals c squared. What we are going to do, and I'm pretty sure that we did this last year, is without spending a crazy amount of time, we're going to make a little graph here, and I'm only going to give us quadrant 1. So here it is. And we're going to do a couple arbitrary points. And I know we did this last year, so we're going to go kind of quick through it. Let's say I have a few points on this graph. And just for fun, we'll say we have this point. That's awesome and wonderful. And we'll call this one, I don't need any numbers on here. Let's just say this is the ordered pair x sub 1 and y sub 1. It's my first point. Okay. If I wanted another arbitrary point on this, if I find crumbs, you guys will be in here vacuuming. Yeah. Cool. All right. Give me another point. What should I name the next one? X sub 2, y sub 2. Okay. So I'm going to put that one arbitrarily down here. X sub 2, y sub 2. Now, we have two wonderful ordered pairs. From these ordered pairs, could we make a line segment connecting them? Yeah, absolutely. Between any 2 points, there's a unique line that runs through them, or a section of that line that we call a segment. I'm going to go ahead and add that. Okay. Pythagorean theorem deals with what sort of triangle? How on earth are we going to use Pythagorean theorem here? Because I don't even have a triangle. Oh, we could make it a triangle. So if I start at this point, Kian, I like your idea. Where do you want me to go? Down. So we're going to go to x1, y1, and we're going to drop straight down. I'm going to change color just so that if you're watching the video after the fact, you can see what we did. But it dropped straight down, and I'm only going to go to here. Could it go further? Indeed. Okay. Well, that's still not a triangle. We don't have a closed shape. That's two sides. Ronaldo, what do you want to do to make this a right triangle? So now we'll just go ahead from here, and we'll go straight right. So we have a vertical line dropping down from x1, y1, and then a horizontal line coming from here. And if you extended them all out, and I wouldn't do this, it's going to make it ugly, but you would have this, and we just selected portions of it. Okay. We get 30 seconds from the time I ask a question. Okay. Here's my challenge for you. Two things, and we'll go a minute. First one, I want you to find me the ordered pair of that red point on the bottom left, where the right angle is. Find me that ordered pair and write it out. And then after that, can you find me a way to make this become the Pythagorean theorem? Cool. I want you to write the ordered pair. We'll call it P for now. Find point P, and then show me that this is the Pythagorean theorem and how we're going to work with it. We might go 2 minutes, but I want you guys to talk it out with your neighbors. You can turn around if you need to. If your group doesn't have anything productive, you can stand up and go talk with somebody else. 2 minutes. If we're at this point, and I can put a number here temporarily if you'd like, let's do that. Let's say that's at 5. Let's say this is the point 5, 3. And I'm just making this up. You do not need to write this part. Is this, give me the x-coordinate of that point. Right here now. So 5, and maybe it's a little lower, 5, 2 or something. What about down here? What's the x-coordinate? 5. But I don't need to call it 5. That was just to make us think about it a little bit more concrete. If this is x1, is this point right here still x1 and x1? So what's the x-coordinate here? x1. How do we use that same idea and expand in the other dimension? The y. Same thing. If we're at y2 down here and I'm going in a horizontal line, does it ever change y value? No. So I know that this ordered pair must be x1 for the x value. And what about the y value? y2. We now have this lovely ordered pair. We don't have the Pythagorean theorem yet, but we're about to. We don't always have to label these, but you guys always say a squared plus b squared is c squared. If you went to school elsewhere, you might say x squared plus y squared is z squared, one of those two. But help me out here. One of these sides, I don't really care which is a, which is b, but do any of these sides have to be c? Which one has to be c? So if we think about this as c, for no reason, I'm going to call this a and this one b. Those could be swapped, and that's okay. Why on earth would I label a, b, and c? Yeah, those are the lines. I think that we could say sides of the triangle. So if we want Pythagorean theorem, we know a squared plus b squared is c squared. Okay, well, let's keep running with this. So we'll just write that to start. A squared plus B squared is indeed equal to C squared. Well, what if I wanted to just find the length of part A of this, or just part B? Could we write an expression for those? How? How do we find A? Well, let's just commit to that one first. So I like where you're going. You're trying to manipulate it, but can you say yours again? Isolate it. What do you mean?
Like move the B squared to the other side of the equal sign.
Okay, so you're trying to do the same thing, and you're allowed to, right? We can add, subtract from equal signs, but forget about the Pythagorean theorem. If I just wanted to know the length of A from that blue point to that red point P, how could we find that vertical distance? You just subtract, right? Like, what should we subtract? Y1 minus what? Y2. Now, is it possible that this isn't really to scale and it would come out negative if we did it? We don't want a negative side, because maybe I did Y2 minus Y1 for some weird reason, but it would be negative. We can't have a negative length. How on earth could we remedy that? What gets rid of anything being negative? A square will do it eventually, and we'll clean it up with a square. What about just normally? Because if I measure that as -4, there's one operation they'll say, no, don't think of the -4, just call it 4. I'm absolutely sure you guys have seen this. Hey, there it is. Cool. So check it out. If we want A, I'm going to use Jade's idea, but I'm going to include the absolute values. I think it was Jade. If it wasn't, I'm sorry. I'm going to use absolute values. So if we stick with it, Y1, what are we subtracting? Y2. That gives me the length of A. Okay, and then what happened to A in our Pythagorean theorem, allegedly? It gets squared. Plus, what's the length of B using the same idea? So I'm not going to use B1. X, right? And if we're looking at the picture, my mind really wants to write x2 minus x1, but I'm going to say consistent. And thank goodness we're using the absolute values of these things. Squared should equal C squared.
What does it show that either A and B are those inside that?
I'm sorry?
What does it show where A and B are those that?
Well, because we labeled A and B on this, I know that this vertical distance is just between Y1 and Y2. And the bottom side of the triangle, which is B in our example, just happens to be the difference in the x's. I'm just plugging in for A and for B. So the first one looks like A to me, because this is a change in Y on our vertical scale here. And then the second one, the change in B, or the length of side B, looks like that change, which looks like it's be this one. Okay. All right. Now, as we look at these, something awesome happens. If I wanted to solve for just the length of side C, which is what the Pythagorean theorem allows us to do, what's the only thing we have to do? How do I make it so it says equal C instead of equal C squared? The square root. Now, if I take the square root of the right, I also must square root of the left, right? We have to do both sides of the equal sign. So we're going to be kind of fast and loose with the notation here because it's pretty standard. If I'm squaring it, Liam, you made a comment a few minutes ago. Like, I used the absolute value here just to make sure we could think it out. But why don't I really need them? Whether it comes out positive or negative, what happens when you square a number? It turns positive. So do we have to worry about it at all? No. Which means we have our lovely equation spitting out in one more line. One step by using that square root property, we, instead of starting at Pythagorean theorem, we end at the distance formula. The distance formula gets spit out on this very next thought. The distance formula. Now, I'm just going to get rid of the absolute values, and I am going to write it as, we'll do a squared plus b squared equals c, but I'm going to write it backward. So I'm going to say c. What would be left over here? I took the square root of the side with c squared. So I have to take the square root of the other. Boom. And then I'm going to drop my absolute values. And what's cool about the distance formula, remember, is the order doesn't matter. Because that squaring part, it just works itself out. We can say that this is just, in parentheses, y1 minus y2. We square that. And we have plus x1 minus x2. And we square that. One step of algebra away, and we clean up, and we arrive at the distance formula. How many of you guys honestly remembered the distance formula before we wrote it just now? Fair. Okay, if you can remember Pythagorean theorem, you'll always be able to derive it using this exact same technique. But really, I think we'll get enough practice to just use it. Okay, questions? Feels okay? Feels awful? Okay, do you want to switch and go do a problem with this, or do you want one more topic and then we'll do problems that involve them both in just 2 birds, 1 stone situation? Second one? Okay, so we talk about distance. That's all fine and dandy. Some of the things that you'll be doing on the homework this evening that we might not get an example of in class today is you're going to determine whether or not a triangle given points is a right triangle. All you have to do is check if the Pythagorean theorem is satisfied. If it's not, then it's not a right triangle. What if you do it and 2 of the sides are the same, but the third side isn't? What kind of triangle is that? 2 of the sides the same. Ooh. It's isosceles. What if all 3 of the sides are the same length when I do it? Equilateral. They can't be right triangles at that point. Not an equilateral. Okay, so beyond the distance, one of the places that we might worry about on a segment is maybe I need to know the whole length. Maybe I only need to know halfway through it. The point that lives halfway through that segment has a name. The midpoint. Does anybody remember the midpoint formula? It is something over 2, and there's 2 parts to it. Can you think about a diagonal line, segment C on this one? Can we think about that as just being a horizontal line and a vertical line put together? Can you go half of the way along that vertical line? Can you go half the way along the horizontal line as well? You just add them up and divide by 2, right? We just average it. We'll just put those 2 things together and we have our midpoint. Find the average of the x's and the average of the y's. Now, that's easy to say, easy to forget, unfortunately. So we'll sneak it in here. We have the distance formula. And as we're kind of pushing past that, we also have our lovely midpoint formula. Midpoint formula. I can't figure out which way I need to look in my classroom right now. I feel like I just walk a bunch of small circles in this little area. Okay, if we want the midpoint, and I'm going to keep referring to this picture that we have right above, if we want the midpoint, we're not going to think diagonal lines. We're going to think about its components, the vertical and the horizontal. What should come first in our ordered pair as we're thinking about it? X. So I'm just going to say the midpoint formula is easy. I'm going to call it point M for midpoint. And if we want the X values, how do we find the exact middle of this one? Of segment A. I'm sorry, we're doing X's first. That's my bad. Sorry. How do we find the middle of B? This point right here. What are we averaging? So it's not subtract. How do we find the number that's exactly halfway between 10 and 24? You add them and divide by 2. So somebody said that. Somebody said something else, but that's okay. We just add them. X1 plus X2 gets me everything. And then we do what? Divide by 2. Piece of cake. So here's our first. We have the first half of it. What about the y coordinates? Love it. Okay, I think it's easy to get goofed up on these formulas because one of them uses minus, one of them uses add, right? Like subtract and addition. Do your best to keep them straight. I wish I could give you better advice than that. Okay, none of this is new, but you also haven't done any of this in quite a while. Feels okay. Feels awful. All right, let's do some problems. Okay, I want you guys to do a problem up on the board. And you guys can go in your groups. Are we okay to not assign group numbers yet? And you'll just go to an empty board? Okay, remember, if you want it in your notes, you can take your notebook. If there's writing on the board, you can just erase it. But we're going to knock out at least one problem. Okay, this problem is going to have 3 parts so that every person in your group can write, just so you guys know. You need to switch markers between. I want us to consider triangle ABC formed by, and let's get some nice points on this guy. I want triangle ABC where we have one vertex, at point A, and it doesn't have to be to scale necessarily, at -1, -3, We're going to say point B lives at 5, 1, and point C lives at 2, 4. Okay, your job is on this problem is I want you to determine what type of triangle this is. What type of triangle? Now, this doesn't feel like a 3-part question, but I'll tell you it is. And between each part, I want you guys to switch markers. Cool. Yep. So my only question for you is, what type of triangle is this? I would not spend a crazy amount of time graphing it. You'd certainly want to have the graph up to at least reference, but it doesn't have to be perfect. Cool. Do it to it, and we'll be back together in a moment. If you are watching this video on the road, go ahead and pause it now, and I want you guys to work this example together. Remember that I will be having you show me notes when you return, but pause it now, and when you resume, you will see a detailed answer to this. And I will see you guys in 3, 2, 1. So a couple things. You can graph the triangle, and almost every group did, but not every single group did. How did I do this without graphing it? Yeah, even if you did graph it, did we find all the same lengths? Yes, absolutely. If it's a triangle especially, you're not going to get goofed up with it. If it's a bigger shape, you might want to have like a small sketch just to keep it straight. But another question that Liam asked, really, really good question. I have my 3 points, and I want to look really carefully at BC here, and I'll point with this so that people on the road can see it. I want to notice that on BC, because we are squaring stuff, I don't really care about the order as long as it's an x minus an x and a y minus a y. And this is like right where it happens, and I want to just make sure we're all aware of this. If I'm doing 5 minus 2, I did point from B minus the point from C, right? But did I do B minus C on my second part? If I did 5 minus 2, it should have been 1 minus 4 if we're staying consistent. Was mine consistent? No. Why did I do 4 minus 1 instead of 1 minus 4? It's positive. And I know that if I'm trying to square numbers, I'd rather do it with a positive, especially if I'm going to touch my calculator, because it's going to give us the wrong sign if we're not careful with parentheses. You can move them if you're squaring it like this on the distance formula. I will do this 100% of the time. You can, or you don't have to, but we get this value, root 18, which is the same thing that you guys got with consistency. This last one, just to show like bare minimum of work, I'm not showing every little step where minus the negative becomes add the positive. Like, I just know that this is 3 squared is 9. So we'll just do that little step. 9 plus 7 squared is 49. And I know that this is root 58. Okay. One person, I don't remember who, but somebody asked, should we use our calculators? I don't think so. Why do we just want to stop here instead? It's not going to give us a better answer if we approximate it anyway. In fact, sometimes it can be harder. Was this a right triangle? No, there's no way that it's going to work out. What's the longest side of this triangle? Root 58, AC. Okay, so we have the longest side. Now, if we approximated this, we're going to see it's not any different, but we don't have a right triangle. We don't have an isosceles or an equilateral, which means you guys all remember this word awesome. It's a scalene triangle. All the sides are different. Now, therefore, it's scalene. That's it. And you don't have to jot this down. I have one more comment, and then we're done with the first section. Okay, as we're looking at this, you do not have to write this one down, but I want to at least talk about it. The square root part where you don't touch your calculator is crazy helpful. And it's not helpful with decimals, but it's really helpful if we keep it radical. If I got these numbers instead, let's say it's root 12, root 8, and root 20. Those are 3 sides of a triangle that came out. What side's the longest side? Root 20. This would be my hypotenuse if it's a right triangle. Why is the Pythagorean theorem easier here than it is using the decimals? If we square a square root, this all becomes. Why is that so nice? Yeah, I don't have to think about what is 3 point whatever the ugly decimal is squared. I know that root 12 squared is 12. Root 8 squared is 8, and root 20 squared is 20. What sort of triangle was this one? This was a right triangle. Be comfortable stopping a step earlier to make it easier for yourself. Cool. Okay, this was all covered in Algebra 2. It was all covered in geometry. over the weekend, 45 minutes is like the max amount of time I want you to spend. I have an assignment for you. So, we get, bless you. All right, we all want super long assignment? 30 problems? All right, I'm not doing that. Okay, so I haven't checked this yet. Remember, by next Wednesday, I don't know when you guys are getting your computers exactly. Your textbook cannot stay in my classroom, but there is a digital one on here for you. So let's see, below is our assignments. And I'm gonna not put like the actual stuff we did, I'm just gonna put the assignment that day. Okay, so it's 8/21/26, and this is homework 1.1. Move it over here. You will find this waiting for you on page 8. And I want you guys to do the following. I want 17 through 27 odd. 17 through 27 odd. And do you want a plain problem, a sport problem, or a money problem? Sport? Oh, we can do both. 38. And then let me see if there's any other fun ones we want. I'm okay with that. All right. So I'll go check the schedule again because I don't remember what time class started or what time we get out. But Monday at the start of class, we'll go over this. We'll see if I collect it or not. I'm sure I will. It's the first one. But sweet. Here's our homework for the weekend. If Fred or Declan or Sebastian ask, please encourage them. They'll see that this was posted, I imagine. But if they ask, be sure to tell them, yep, it's on Google Classroom. I'll go check the time. I want you guys to get started, assuming we have a little time left. Yeah, we go till 55. We got 5 minutes. You'll be able to knock out the first 2 or 3 or 4. Benj, I don't want you to be on an island by yourself. If other people move, that's okay, but I want always to have somebody to work with. Cool.